So let's review domain and range. So domain, of course, is your set of inputs, and the range is the set of outputs. And so at this point, you have seen domain and range in a variety of your classes, especially Algebra 1 and Algebra 2. And you've done domain and range with basic things like lines and parabolas. But what if you have something here where you have a lot going on in this one? We have a square root, we've got something squared, we've got a fraction. So we've got a lot of function composition here. How do we figure out the domain and range? So domain you can always pretty much do without a calculator. So you should be prepared to find domain without a calculator. Range, it depends on the type of problem that you're given. In this particular one, I want you to be able to do this without a calculator, and we'll talk about how you could do that. So let's start with domain. So domain is the set of inputs. So I see a couple things. First, I see a square root, and a square root has limited domain because you can't take the square root of a negative. So if you can't take the square root of a negative, then what's inside has to be greater than or equal to 0. Okay, so when you take the square root, you can't take the square root of a negative. So therefore, all the values must be greater than or equal to 0. So we're going to subtract 1. And then you'll recall that when we multiply or divide by a negative with an inequality, then that means we have to switch the sign. So we get x is less than or equal to positive 1, which makes sense because if you plug in 1, you get the square root of 0. Square root of 0 is 0, so that's allowed. And if you plug in, a number less than or equal to 1, like 0. So if I plug in 0, I get the square root of 1 minus 0, which is the square root of 1, which is 1, and that's also allowed. So it kind of checks out when I check a couple of points. So I just wanted to double check that that works. So this is part of my domain, but I'm not quite done considering this entire equation here. I also have a function, I have an input x plus 3, and it's being squared. There's no domain limitation there because you can square any number. But can you divide by any number? You have a fraction here, and you cannot divide by 0. So what that means is x plus 3 squared cannot equal 0. Okay, well, that just means x plus 3 can't equal 0 because 0 squared would give me a 0. So x plus 3 can't be 0. So subtract 3 from both sides. You get x cannot equal negative 3. So our domain is the numbers that are less than or equal to 1 and where x cannot equal negative 3. So that's inequality notation, would be kind of combining these two. So I'll say domain, x is less than or equal to 1, but x cannot equal negative 3. So that's one way to write that answer. Interval notation, so this is something you should also feel comfortable with. So we have all the numbers less than 1. So that means we're starting at negative infinity, but we can't include negative 3. So we're going to go from negative infinity to negative 3, and then we're going to stop. And we're not including negative 3 because it can't equal negative 3. And so that's why it's a soft bracket, not a hard bracket. And then we also have the numbers from negative 3 all the way until 1. So I'm going to start at negative 3. Again, I'm not including negative 3. I have a soft bracket there. So I'm going to start at negative 3, but I'm not including it. But I am allowed to include 1 because it's x less than or equal to 1. Okay, so this is another way of writing your domain. Either one would be fine. Okay, now range is your set of outputs. So given that we plug in all these different values of x of our domain, what is our range? What are our y values? So in this particular one, you actually can do it without a calculator. And the reason I can do this without a calculator is because I understand, and I would like you to understand, how numbers work when you plug them into certain types of functions. For example, if you take the square root of a number, and that's a positive square root, that's not a plus or minus square root, that's a positive root. If I wanted it to be negative, there would be a negative on the outside. Well, a positive root gives me positive numbers. So it doesn't matter what domain value I plug in, my numerator will always be a positive number. Like if I plug in negative 4, that'd be the square root of 1 plus 4, which is the square root of 5, which is a positive number. If I plug in 1, I get the square root of 0. So it's going to be 0 to positive numbers for my numerator. Okay. And then in my denominator, so I shouldn't say my numerator is always positive. It's always positive or 0. It's greater than or equal to 0. In other words, my numerator can never be negative. Okay. And then my denominator, I'm taking all these x values and I'm squaring them. Okay. Well, if I square numbers, those are always going to be positive numbers. So I'm always going to have positive divided by a positive. So I already know I'm not ever going to have negatives. I know that x will never be less than 0. So my question is, will it go all the way to infinity? Well, we have a vertical asymptote here. So let's talk about the behavior of vertical asymptotes. I have a vertical asymptote. If I plug in -3, it's undefined. And I know my graph will always be above or equal to the x-axis. If I plug in 1, I get the square root of 0 divided by 16, so it's 0. So if I plug in 1, I get 0. And then I can, if you want, you can start plugging in other numbers to see what's going to happen here. If you plug in 0, you get 1/9. If you plug in, let's say, -2, that would be the square root of 3 over 1, so the square root of 3, whatever. So I'm going to get a bunch of positive numbers. But the question is, will it go all the way up to infinity, or is it going to have a maximum and go back down? Well, with vertical asymptotes, you will always approach infinity or negative infinity on either side of a vertical asymptote with a rational expression. So if I have a vertical asymptote because I'm dividing by that term, then it's going to have to go to infinity or negative infinity on both sides. But here's the thing. I already know it's not going to go to negative infinity because I already know it can't be negative. It's squared. That's only going to give me positive values in the numerator because it's square root and positive values in my denominator because it's squared. So it has to go to positive infinity. And you can check if you plugged in -2.999, -2.999 plus 3 is going to give you 0.001. Square that, you get 0.0001, which is like 1 over a million. And then you take the square root of 1 plus 2.999. So you get something very close to 4. So the square root of 4, you get something close to the square root of 4. So you get something close to 2. Well, 2 divided by 1 over 1 millionth would give you 2 million. So you could plug in numbers to see what happens, but either way, I know it's going to approach infinity or negative infinity. So I actually don't know what the other side of this looks like, but I do know that it's going to go all the way to infinity on both sides of this function because it has to, because it's a vertical asymptote, and that's the behavior next to vertical asymptotes. You're always going to go up to infinity or down to negative infinity. And because I can't get any negative numbers, it can't be negative infinity, so it has to be positive infinity. So my range is y is greater than or equal to 0. And in interval notation, that's going to be 0, hard bracket, because we're including 0, all the way to infinity. So you should have a general understanding of vertical asymptotes and the behavior around it. And then, of course, all of the things we discussed with domain, like what happens if you take, if you have a fraction, what happens if you have a log? There's certain values you can't input into these types of functions. So just keep that in mind as you do those problems. All right, so number 12 here in your notes. So this is an example of finding or estimating the area under the curve from 1 to 4 using trapezoids. So I just want to point out that the actual area from 1 to 4, if I was to find the actual area, it's always the area starting at the x-axis and going up all the way to the function. So the actual area is whatever this shape is here. And this is not it's not a trapezoid, it's not a rectangle, it's not a triangle. So whatever we would call this shape, that's the actual area. But we can't find that actual area without more complicated calculus, which we'll get to later on in the year. But right now, we're just estimating the area. So one way to estimate is to use trapezoids. So we are going from 1 to 4. That is a total width of 3. Right? That's a total width of 3. Now, if I split that into 3 trapezoids, 1, 2, 3, that's a width of 1. Okay, so you take your total width of the interval, divide it by the number of trapezoids, or in some cases rectangles, and we get 1. Okay, so the width, delta x, is 1. So that means my first trapezoid, I'm going to start at my endpoint of 1, and I'm going to go up to the function. And then it's going to end 1 unit later. If I start at x value of 2, go all the way up to the function, and then I connect those with the line, and that gives me my trapezoid here. That's my first trapezoid. And then I continue that pattern until I have 3 trapezoids. Okay, so I have another one here. Okay, and then lastly, well, okay, 4, the function is already at the x-axis. So how do I go up to create a trapezoid? I don't. I have a triangle here, and the height of the one side of the trapezoid is 0. So if you have a triangle, that doesn't mean you should create your own weird trapezoid. A triangle is a trapezoid with one side equal to 0. So I want you to think of trapezoids, I'm sorry, I want you to think of triangles as trapezoids where one of the heights is equal to 0, and that's okay. So even though it doesn't look like a trapezoid, if I was just like a little bit tiny above, it would be a trapezoid, but I'm going down to the x-axis here, so it's just a triangle. Okay, so I'm just going to, at this point, I don't want you to try to get fancy. I don't want you to use sigma. I don't want you to do anything except for add up a bunch of trapezoids. So my first trapezoid has a width of 1, and then I average the heights. Okay, my first height is 3, my second height is 4, and I average them by adding them up, divide by 2. Okay, my second trapezoid is a width of 1 times the average of your heights. So your first height is 4, your next height is 3, and we divide by 2. And then my third trapezoid has a width of 1. My first height is 3, and my last height is 0. Okay? All right, so t sub 1, 7 halves, t sub 2, 7 halves, t sub 3, 3 halves. So my total area is 7 halves plus 7 halves plus 3 halves, which is 14, 17 halves units squared. Okay, and you don't have to get fancy. Don't make it a mixed fraction or put it in decimal form. If you have fractions that have common denominators, don't put them into mixed form and then add. Don't put them in decimal form and then add. Just add the numerators, keep the common denominator, circle your answer, you're done. Okay, this is an exact answer, we're fine. And that's it for that problem.